Now the figure 1 is about the architecture of a proposed SGD-LSTM method. The user is directed to the instruction detection phase where the data preprocessing and the access occur after registering with the credentials. The data preprocessing module does data conversion, data normalization, data sanitization. The preprocessed data is categorized and accessed using the SGD, LSTM, BEA algorithms. The instruction protection intrusion protection phase is the final stage of the suggester model and it is in authentication via user login identity verification status. Suppose entered data is coordinated with a registered information in the user is confirmed to be legitimate user. If the data is mismatched, the user can be an invalid user, considered as an invalid user. Now we will discuss about the description time analysis. That is decryption time analysis. Decryption time contrast of the SGD LSTM method with existing methods is characterized in a table 2. Figure 5, the data demonstrates that the proposed method outperformed the other technique in every way. SGD LSTM process, for example, took only 2.125 seconds to decrypt the data with 20 nodes. In a contrast, other existing methods such as RSA, DAS, AES, DNA, RC4 DNA took 10.763 seconds, 9.632 seconds, and 7.543 seconds, 6.345 seconds, and 4.156 seconds respectively. Corresponding for 120 nodes, the SGD LSTM method decrypts in 3.654 seconds, while other systems techniques such as RSA, DES, AES, DNA, and RC4/DNA decrypt in 12.876 seconds, 10.672 seconds, 8.862 seconds, 7.432 seconds, 5.876 seconds respectively. These graphs represents x-axis of a number of nodes and y-axis decryption time in milliseconds. This is a graph diagram of a decryption time analysis. And encryption time analysis. The encryption time of the HGD LSTM method is compared to that of other methods. The data demonstrate that the proposed method outperforms the different strategies in every way. For instance, with 20 nodes, the SGD team encrypts in a 3.652 milliseconds, while other existing systems like RSA, DAS, AES, DNA, RC4 DNA take 13.749 seconds, 10.294 seconds, milliseconds, 9.465 milliseconds, 7.346 milliseconds, 5.845 milliseconds respectively. Similarly, the SGD LSTM method encryption time for a 120 nodes is 5.364 milliseconds compared to the 14.854 milliseconds, 11.345 milliseconds, 10.187 milliseconds, 9.143 milliseconds, 7.132 milliseconds for the other existing techniques. This is the graph diagram of the encryption time analysis, and the x-axis shows the number of nodes and the y-axis shows the encryption time in milliseconds. F-score analysis. The SGD LSTMA strategy is compared to the other earlier techniques. The graph demonstrates that the cloud approaches improved performance as measured by the F-score. For instance, RSA, DAS, AES, DNA, RC4 DNA models have a F-score 87.43%, 75.45%, 81.76%, 78.75%, and 84.92%, respectively. SGD LSTMA, on the other hand, has 20 nodes and an F-score of 89.73%. However, SGD LSTMA model performed best with a variety modes. Similarly, the F-score value of the SGD LSTM under the 120 nodes is 93.76%, whereas it is 89.54%, 78.21%, 84.86%, 81.14%, and 86.95% for RSA, DES, AES, DNA, and RC4 DNA model respectively.
RMSE analysis. Cooperative RMSE analysis of the SGD LSTM strategy with other previous techniques are shown in the down figure on the table. The graph shows that the cloud strategy produces an improved performance with the lower RMG value. The RSA, DES, AES, DNA, and RC4 DNA designs all have slightly better RMSE than SGLE strategies. which has the RMSE 52.14%, which is 20 nodes. The SGLD design, on the other hand, has shown maximum performances across a wide and nodes while maintaining lower error. Similarly, RMSE values of SGD under 120 nodes is 55.63%, whereas it is 76.47%, 70.54%, 66.74%, 63.96%, and 59.15% for RSC, DES, AES, DNA, and RC4 DNA modules respectively. This shows the down graph analysis, RMSE analysis, and everything, number of nodes, where the percentages and everything. Now let's see the conclusion. The ultimate consumers of the cloud are expanding with their use of for personal and professional purpose due to the enormous increase in data and computing technologies. The efficient and adaptability computing and storage solutions technology to the requirements of the applications and the cause of this section. On demand, the cloud offers computational and data services. The cloud makes data storage more accessible and adaptable, but unwanted attacks and operations still exist. Sensitive data could be covertly stored to the cloud server. Data and security is essential as a result. Here we combine stochastic granted descent along short-term memory with the blowfish encryption technique to identify the prevent unauthorized cloud access. The proposed system is divided into three parts: instruction detection, user detection, and instruction prevention. The SDL LSTM classifier is used to forecast put data, cloud data, access in instruction without access. The Goldfish encryption algorithm is used to verify the unauthorized person during the phase in instruction of to limit access in information environment, cloud environment. Thank you.